Okay, in this video, I will solve some problems about the oxidation reduction, the redox reactions. The question is, show the oxidation and reduction in each of the following equations and write half reactions and overall reaction. You will notice that none of the equations written have oxygen. So there is no oxygen in these equations. Since there is no oxygen, so we have to go or to look at the oxidation state of each element and then decide where is the oxidation and where is the reduction. Let's start with the first one. Okay, the first one is AlBr3 giving Al and Br2. Okay, the first step in any problem like this is to know the oxidation state of each element. Let's start with Al. Here it's inside a compound, so it will have a charge, it will have an oxidation state. Aluminum is in a group 3, so it will have an oxidation state of +3. Br, each Br will have an oxidation state of -1 because it's in a group 7. So -1. Now, Al, because it's a free element, so the oxidation state is 0. Br2, free element, oxidation state is also 0. Okay, now let's compare the oxidation states of each element. Al +3 to Al 0. From +3 to 0, this is reducing of the oxidation state, so this is reduction. From +3 to 0. Br from -1 to 0, from negative to 0, so this is increasing in the oxidation state. So, as we said before, increasing in the oxidation state is oxidation. So, Al +3 is reduced to Al, and Br -1 is oxidized to Br2. Let's write the half equations of each one. Let's start with Al. Al +3. As we said before, from +3 to 0, this is reduction. Reduction is gaining of electrons, gaining of 3 electrons. How would you know that you're doing well, or you're solving in the right way? +3 and -3 equals to 0. The sum of the charges here is 0. The charge here is 0. The charges should be balanced in the equation. Okay, this is the reduction, the oxidation, Br minus, and here it's Br2. Bromine, as you know, it's one of the elements that exist as a diatomic molecule, so it should be Br2. I can't omit the 2. Because it's Br2 here, I have to add 2 here. Okay? Each bromine atom went from being -1, or from having the oxidation state of -1 to 0, so it lost an electron. Because we have 2 bromine atoms, so 2 electrons are lost. So plus 2e negative. So this says, as we said, for Al, it's gaining of electrons, and this is losing electrons. 2 electrons lost. Okay, try to the overall reaction, which is in the question. We have to make the numbers of electrons equal. So we will multiply this by 2, and we will multiply this by 3. By multiplying the first one by 2, we will have 2Al plus 3 plus 6 electrons. 2 by 3 equals 6. 2Al. And by multiplying the second one by 3, 3 by 2, we have 6 Br negative, 3 Br2 plus 6 electrons. 6 electrons with 6 electrons, they omit each other, so 2Al plus 3 plus 6 Br minus 2Al plus 3 Br2. The only thing that I did here is transferring the elements inside each equation. Al plus 3, 2Al plus 3, 2Al plus 3, 6 Br minus, 6 Br minus. After the arrow in the products, 2Al, 2Al, 3 Br2, and 3 Br